All right, today we have a question on the board, and it says a block of aluminum is heated electrically by a 30-watt heater. If the temperature rises by 10 degrees Celsius in 5 minutes, find the heat capacity of the aluminum. Find the heat capacity of the aluminum. All right, this question is a very simple one to solve. And then what we're going to do is just to go straight to the formula and then use it to solve. You remember that a substance can be used to heat up another substance. In the same vein, electricity can also be used to heat up a particular substance. So this is a situation whereby an electric heater rated 30 watts is used to heat a piece of what? Aluminum, a block of aluminum. So we're going to make use of the relationship that the electrical energy is equal to heat energy. Okay, that way we now say that electrical energy, let's use EE, is equal to heat energy, HE. All right, so electrical energy is power multiplied by the time. Then this is equal to heat energy is mass multiplied by the specific heat capacity of the substance, then multiplied by the temperature change, theta. All right, so this is the formula for the conversion from electrical energy to heat energy. You remember that energy can neither be created nor destroyed. So the total energy here from electricity, from this electric heater, has been converted to heat up the piece of aluminum, raising its temperature by 10 degrees Celsius. So the power has been given to us to be 30 watts. So we have 30, all right, then multiplied by the time they gave it to us here in minutes. Okay, we're not going to make use of minutes to solve. All we're going to do is to change these 5 minutes, we're going to change it to seconds. How do we now change it to seconds? Remember that 1 minute is equal to 60 seconds. So this 5 minutes here is equal to 5 times 60. All right, let's put it here. 5 multiplied by 60. Okay, and this is equal to the mass times specific heat capacity times the temperature change. Now, you have to notice that this product here alone, this MC, is what we call the heat capacity of the substance, the heat capacity of the aluminum. All right, so let's still represent. Remember that what we are calculating here is the heat capacity of aluminum. So this quantity MC is the heat capacity. Now, let's just write MC because that's what we're looking for. Then multiplied by the temperature change. This temperature change is the value given to us here, that is 10 degrees Celsius. So we have 10 in our solution. So all we need to do is now say 30 multiplied by 5 times 60 is 300, right? Is equal to MC multiplied by 10. Okay, so for us to be able to get the value of MC alone, then we're going to divide both sides by the coefficient of MC, which is 10. Okay, so divided by 10, divided by 10. So this 10 will cancel this 10. And of course, this 10 will cancel 1 0 here. So what we have left is 30 times 30. So what it means is that our MC, which is the heat capacity, is equal to 30 multiplied by 30. And when you say 30 multiplied by 30, it now gives you 900 joules per Kelvin. 900 joules per Kelvin. That is the heat capacity of the substance. Thank you very much. I hope this is helpful. Please like, comment, and share. Bye-bye.